Hey everybody, Monty Reed here with a Jetpack update, and I've just had a lot of fun with the Arduino Facebook group. I put up a question about temperature sensors, and there was so much feedback. Of course, thermocouple, a lot of people came up with thermocouple and amplifiers. And I want to say thanks to everybody, Anthony for being the first one to reply. And then, of course, everyone else who started kicking in. Darwin, a nomination. I hope not. I hope not. So far, it's been going well. And the reason I'm looking for the temperature sensor is to make sure that I don't get a Darwin award. But I do plan to fly. So I have found thermocouples and also a couple different units that do talk to the Arduino. One of the challenges, most of them operate in the lower range, the 500 Celsius range. And I'm hoping that the output exhaust temperature will be around 750 Celsius, but some jet engines do get up to over 2000. And of course, if that happens, we'll have problems because my engine body is made of steel, and of course, steel can start to melt. But one of the greatest ones was from Phil here, the furnace temperature sensor at 750 degrees Celsius. And so because of all of those, I've gone to AliExpress and put some stuff in my shopping cart, and then also found some other fun websites. This Adafruit website had a really nice interface, but all of the probes that they are selling, I haven't found any of their probes that go over 500. This particular one, the glass braided one, goes up to 500 Celsius, but again, we're looking for higher temperature ranges. So haven't found one in that higher range. Like this one says 125 degrees Celsius is the limit. So looks like this thermocouple amplifier is designed for the Uno, as obviously it's pictured right there, for some from Adafruit. So I'll probably get one of those ordered, but I do got to find a thermocouple that can handle those higher temperatures. So still looking for that, still looking for code. Of course, obviously, as I mentioned down at the bottom, I'll just jump down to the bottom here. I've got a sketch from Arduino. There it is. And it's just the example sketch that was written by Tom Ego on December 22nd, 2012. And it's pretty simple. I posted it on the YouTube channel, a link to this sketch. Of course, the challenge is this sketch is designed to read the temperature sensor that is on board on the Explorer. That's the temperature sensor right there. And when you hook it up, it reads the temperature. And if you use the serial monitor, then you can see that. So what I need help with is getting the data from the serial monitor back into a sketch so I can make adjustments in real time. So I can hook up the Explorer to the computer. I can upload this. Let's compile to make sure. All right, we're done. And then we will upload. There's been a series of beeps letting me know that it's uploaded. It says it's done uploading. And then we'll go up here to open the serial monitor right here. And it's giving me the temperatures right there. And so we have that. That's nice to look at. That'll help with the test bench. But, of course, these are just room temperatures, and of course the Explorer won't handle those temperatures inside the combustion chamber, obviously. So that's why I want to have that interface. So I'll have to change the sketch so that I can, first of all, read from an external probe, and then secondly, I'll need to use the data in real time to make adjustments of the fuel and other things. So that's part of a challenge that's ongoing, and we are having a lot of fun with the Arduino community. So what I will, I'm actually going out of town, so when I get back, I will be doing some searching for, of course, I got to wait for these to get here. Mark's got one here, exhaust gas temperature sensors for diesel. And I was talking to a mechanic. Josh was telling me about diesel, when I was asking about diesel injectors. He was talking about those. So it's just a matter of finding diesel engine sensors that can talk to the Arduino. So again, it comes back to the interface. So here's one for a GM with 2-wire, but again, it comes back to getting it to actually talk to the Arduino. And here's a guy, Zach, is talking about a $1,500 sensor. Well, that's too much because I'm obsessive with data collection, especially at the test bench. I'm looking at, wanting at least 10 sensors for one engine, because I need to test the temperature in and around the combustion chamber. Let's see, yeah, question, doesn't have to be so close to the flame. And so this is a good question. For the test bench, I want to test in the combustion chamber, at the exhaust. There's a lot of things I'm testing for. One, I want to make sure that it's not so hot that it burns my legs. And so I need to know the safe distance from the exhaust tail that's coming out. But inside and around the combustion chamber, typically we will move the fuel line near the combustion chamber to find the sweet spot of 185 to 200 degrees Celsius. If the kerosene fuel gets above to 220, for instance, then it does what's called auto ignite, where it catches fire. And you don't need a glow plug or a spark because it's on fire as it comes out of the tube. But the problem is, if you go above that auto ignite temperature, it can set the fuel lines and the bladder and everything on fire, and the whole thing explodes. And so with a rocket engine that's going to space, it's no problem. You want it to auto ignite. The fuel lines are right inside the combustion chamber, because once the countdown hits the word liftoff, they're going to burn every drop of fuel in the thing. But with the jetpack, we want to be able to control it and even come in for a landing without using up the fuel. So what we may end up doing is actually build a preheat chamber next to the combustion chamber, and then have flaps to allow heat in and out. And if you don't preheat the fuel, then it cools down the combustion chamber and reduces thrust. So good questions. And of course, for people who are excited for the progress, you can check out the YouTube playlist. There's a YouTube playlist list called Thrive Arduino Jetpack, and that will have all of the updates. For now, I've put some of the discussion about the suit over here, just a little bit about me. I'm a NASA Space Grant Scholar. My background is developing the powered exoskeletons. I have the world record for distance in walking in powered exoskeletons, and the next project that we're working on with the exoskeleton, and we'll update that on the channel too, we'll be building a model of the exoskeleton that can do a 100-yard dash. And then eventually the jetpack will be attached to the exoskeleton so it can fly like a real Iron Man. And so I just have posted on here just an overview of some of the nozzle configurations, iteration 1, 2, 3, 4, 5, 6. So we're up to 6 different prototypes so far. And we will, once my fuel pump gets here, I'll be pumping in kerosene into the flame. So we'll have a hybrid of kerosene propane. And of course, the challenges around the temperatures, I mentioned here the flash point of kerosene and that auto ignition temperature. My background is with the PSOC, Programmable System on Chip by Cypress, and we use those to control the powered exoskeletons, and they've been great. I just wanted to try an Arduino for this because there's so many people out there, so many friends. Booty is one of the guys who's told me a lot about the Arduino, so I want to thank you for pushing me in that direction. And but what I'll do is I'll create a blog eventually, and the blog will be posted at the beginning of this Arduino Jetpack playlist. And as more videos get up, they'll just be added to the playlist in order. And so, again, there's a couple other things. This tantalum carbide is something that Tapan Pandy, sorry if I butchered your name there. I went to the website and they don't have pricing, so I have to click on this and fill out this form. So I'll wait to hear back and see how many of those I can buy. So we'll give that a shot. That's a great idea. And I always like to have stuff off the shelf. I mean, if I have to make my own temperature sensor, I will, but I'd rather find something off the shelf where the work's already done so I can get to flying this thing. I mean, I could spend a year developing temperature sensors, but that's not what I want to do. I want to fly. I want to fly the jetpack. So, and then Greg Boyles had posted a bunch of YouTube videos, which are really cool. And the pulse jets are awesome. I looked into the pulse jets. I remember those. They're really cool. They're loud and cool, but usually the pulse jets work really well for things that roll on the ground and also aircraft that are moving forward, because you have to have that air flowing in and out the back. And the problem with the jetpack is there's not air flowing in automatically because of forward momentum, because you're just sitting there hovering. And so there's a challenge with pulse jets. Their thrust ratio is just not good enough. And of course, I've been inspired by some other jetpacks out there. For decades, I've been following the hydrogen peroxide jetpack that was done back in the 60s. And I saw this in the Smithsonian Institute when I was very inspired. Also, there was a TV show called The Ark. And of course, James Bond. This was the thing that really got me excited about jetpacks, is James Bond flying this thing. But of course, the problem with this particular one was, for decades, the jetpack's flight time was just over 30 seconds. And so more recently, a gentleman developed some mini turbine jetpacks. And he's flying around more like Iron Man, and he's got a 3-minute flight time. And Browning from the UK has been come up with this amazing system with 5 jet engines, kerosene fueled, and he's a speed of 51 kilometers per hour. And he has set a new world record, which is inspiring and awesome. And if I had $30,000, I would buy these jet engines. They cost about $4,200 each. And I would just go ahead and slap one together myself. But I don't have the funding for that right now, so I'm just going ahead and experimenting with building my own. And it's kind of fun to do that anyway. I could just buy the jetpack from him. He's selling them for $250,000, but again, I don't have that either. So in the meantime, we're having some fun. And again, some folks, Jeffrey gave me a link here to Arduino temperature sensor, very helpful. And Ahmed was asking for the code, so I went ahead and listed the code there. And someone is typing now. So we're going to continue this conversation on the Facebook page, and here on the YouTube channel. You can put comments in here, or you can, if you're an Arduino enthusiast, you can go to the Arduino Facebook group. And I want to thank everybody for participating, and I want to thank everybody for helping me out with your input. I'm looking forward to sharing more with you. This is Monty Reed for YouTube and the Jetpack Update. Have a great day.